Welcome back, everyone, for a great afternoon. You have two great speakers and one myself who's just okay because my voice hopefully will not give out. But I'm Mark Hamilton. I'm your MC for the afternoon. We'll get started with Deepu Talla. He's the general manager and VP of our embedded products division. He'll be coming up and he'll be talking about IoT and AI for IoT. You know, Taiwan is such an amazing country with so much of the computing systems all the way down to devices being built here in the country. And Taipei has certainly the opportunity to make itself one of the great smart cities and advance the use of IoT technology. So with that, I'll ask Deepu to come up and kick off his presentation.
Good afternoon. The last 2 years, we have seen some amazing achievements in AI. I thought that the I Am AI video at the beginning of the keynote captured it all. We've seen complex strategy games, AI-trained computers are beating the world's best humans. We're seeing AI paint like the masters, the best artists of all time. Apparently, we're going to see very soon an Isaac lab-based robot go to the Augusta Masters. And then we've also seen self-driving cars and autonomous vehicles. So all of this amazing transformation is happening, and NVIDIA has been right at the middle of this AI computing revolution. And many are saying NVIDIA is now the captain of the computing industry. And NVIDIA, if you look at all these, every industry is being transformed by AI. You look at all the AI-powered consumer services, such as OK Google, or if you are an iPhone user, Siri, or if you're using Amazon Echo, or your recommendation engines, all of them are using AI, and they're powered by NVIDIA GPUs. All the major cloud service providers now are providing AI as a service using NVIDIA GPUs. All the major enterprises have adopted NVIDIA GPUs for AI. Top automotive companies for self-driving car are have adopted NVIDIA GPUs. And of course, last but not the least, there are many, many startups pretty much in every industry, from healthcare to infrastructure, to financial technologies, to mapping, to autonomous vehicles, to robotics, you name it. There are over 1,300 startups that are part of the NVIDIA computing ecosystem. Now, all of this has really happened in the last 2 years because of GPU deep learning. As you've seen in the keynote, this is a new computing model where AI is enabling software write software. And most of you are familiar that there is 2 parts to deep learning. The first part is how we create this neural network, so-called training. What used to take weeks, if not months, just a couple of years ago, with Pascal last year, we've accelerated it to a matter of days. And now with Volta V100, it is less than a day. So we've seen enormous progress in terms of how fast you can create and train these neural networks. The second step, once you train that neural network, is to deploy that neural network. And that's called inferencing. In fact, most of the deployment of the neural network or inferencing today is done in the cloud. If you think about it, when we're asking for directions or when we're asking Google or Siri from your mobile phone, the query is sent to the cloud, and there's some AI happening, inferencing in the cloud, and the answer is sent back over the network, back to your phone. Now, that's where most of the AI is happening today. But we're also increasingly seeing that AI is also moving to the edge and not just in the cloud. And we have our NVIDIA platforms all the way from training to inferencing in the cloud using our Tesla platform, and then Jetson for inferencing at the edge. So why do we want to inference at the edge? Why not do everything in the cloud? There's actually 4 reasons why AI at the edge matters. The first reason is that because of bandwidth restrictions. If you think about an application like video cameras, there are hundreds of millions, almost 1 billion cameras that are going to be in the world by 2020 that are streaming data 24/7. And if you're compressing that video using your traditional video techniques like H.264, H.265, and these are typically HD resolution, you're talking about 1 to 2 megabyte or 10 to 20 megabits per second typically. And that's a lot of data, tens of petabytes of data that's generated by these cameras. There is not really enough upstream bandwidth to send all this data to the cloud. So you would want to process as much data possible at the edge and only send selective information to the cloud or data center for higher level intelligence. So that's the number 1 reason why you want to do inferencing at the edge. Number 2 is latency. Think of a self-driving car or an industrial robot. They need to make decisions in fraction of a second. By the time you send the data, if you're sending only to the cloud, there's not enough latency. There's going to be too much of a latency by the time you send to the cloud over the network and get the answer back. So for that reason, you want to do processing at the edge and not in the cloud. Third reason is privacy. Some industries, there is real concern about sending data into the cloud. Think of medical records, for example. So in that case, what happens is that most of this data, instead of being sent to the cloud, is stored on premises in the hospital or somewhere close to the hospital or what's called a private cloud. So if your data is on-premise or in a private cloud, you want to do your compute near where the data is, and that happens to be the edge. And then the last reason is availability of connectivity. Now, where most of us human beings live, there is good connectivity to the internet. But many of these emerging applications, like think you saw some of the examples like agriculture or inspection in uninhabited areas where humans are not anywhere close, there's not a good availability of connectivity. So 24/7 connectivity to the cloud or internet is not available. So in that scenario, you would want to do your processing at the edge and not just in the cloud. So this is why we are increasingly starting to see that AI inferencing deployment is not just in the cloud, it's also at the edge. And in the future, we'll see a hybrid architecture where some of it will be in the edge, some of it will be in the cloud, depending on the application. Now, Internet of Things. Internet of Things, I think, is a pretty broad market. Any electric computing device is, in the future, going to be connected to the internet. Today, our mobile phones and tablets and PCs and TVs, smart TVs, are connected to the internet. But many of the other devices in the home or in the factory are not yet connected to the internet. But in the future, anything that has any electronic circuit, we can imagine that it is going to be connected to the internet. And today, there are already billions of these devices, Internet of Things, in the world. And in the future, you can imagine there's going to be hundreds of billions of devices, maybe even 1 trillion devices in the next several years. And it is a pretty broad market. You know, Internet of Things, pretty much any electronic device can be captured in Internet of Things. One of the popular market is cities, so-called smart cities. Whether you have these cameras for public safety reasons, you have parking meters or traffic lights that can be automated in order to make efficient utilization of traffic patterns and do a good routing. So smart cities is one example. Smart factories, from manufacturing to industrial automation to warehouses, all of these devices are also Internet of Things and are going to be connected to the internet. Agriculture, you've seen some of the examples in the keynote. Everything in the future is going to be connected to the internet as well. Automotive, of course, not only self-driving cars, but trucks and other robots and devices, autonomous vehicles. Healthcare is going to be a huge market also for Internet of Things, from portable medical imaging to medical diagnostics that are going to be done in the home at the consumer level and also in hospitals. Home office, today, other than our phones, tablets, and TVs, we have rice cookers, we have coffee makers, we have washing machines, we have air conditioners. All of these devices are going to be connected to the internet eventually. And then, of course, our personal devices, and then many other markets. So for all of these, Internet of Things, or so-called, you require AI at the edge, we've created the Jetson platform. And you've seen this platform, and this is the one that Jensen also showed earlier. And this is the embedded supercomputer, less than 10 watts for this whole computer. This computer has a mobile processor, it has DRAM, it has Wi-Fi, Bluetooth, flash, all the power management, audio, Ethernet, a complete computer, supercomputer embedded in a module, less than 10 watts, intended for doing AI computing at the edge. And has full desktop Linux, robot operating system, comes with the full CUDA stack, same GPU architecture that is in Jetson, is also in GeForce, it's in Tesla, it's in DGX, it's in the cloud, everywhere the same GPU architecture. Write software once and then deploy it everywhere. And of course, the full software stack. Incidentally, Jetson yesterday was awarded one of the best choice awards by Computex. Thank you for that. And so this is a product that we've announced a couple of months ago, and it is in production and being used by many, many different applications, as I will show you in a couple of minutes. A little bit more detail about Jetson. This is Jetson TX2. The previous generation was Jetson TX1, based on Maxwell, and that has been shipping already for almost 18 months now in the market, and there are several products that are leveraging Jetson TX1 to do AI processing at the edge. And Jetson TX2 is the follow-on version, and both of these modules are actually pin compatible. And Jetson TX2, we basically double the performance compared to Jetson TX1 for the same power, or for the same performance, you can get half the power. So either double the performance or double the energy efficiency, but pin compatible. So we've increased all the processing capability, memory capacity, memory speeds, bandwidth, video processing, everything in the Jetson product. Now that is the hardware. Of course, hardware is central to making the product, but fundamentally, the value add that we provide on top of that hardware is the software stack that comes with Jetson. It is called Jetpack. So underneath, you have the Jetson embedded supercomputer, which has that whole module that I showed you. And on top of that, first of all, it is a full desktop Linux computer. Okay, you could actually build a laptop or a desktop, a Linux Ubuntu-based 1604 desktop with it. And then it comes with a full OpenGL graphics software stack. So it is a complete Linux computer. And on top of that, we've added all the capability for deep learning with on top of CUDA for both TensorRT and cuDNN. We have computer vision libraries, all GPU accelerated for both OpenCV and VisionWorks, which is based on OpenVX. All the desktop graphics capability from latest generation Vulkan and OpenGL, and also multimedia APIs for video, image, and audio processing. And then it comes with complete desktop developer tools. This enables many, many applications to be built in a very fast manner. And there are over 30,000 Jetson Jetpack developers already registered today, and it's continuously increasing because it's so easy to use and so powerful. Given that it is a complete desktop Linux computer and you can use desktop tools, it is very easy to develop. And then with the high performance and low power and the complete AI stack, Jetson is being adopted very, very broadly in many, many IoT applications to do AI processing at the edge. Now, I've been in the semiconductor/technology industry for almost 20 years now, and one of the things that I've never been part of, but I'm part of now, is typically when you release a hardware and you release software on top of it, and then you make a software upgrade, generally my experience with PCs or phones or tablets is that it gets slower. I've never seen something get much faster. It's always slower. Whereas with Jetpack, we have been continuously improving the performance. The first time we launched Jetpack 2.1 18 months ago on Jetson TX1, we achieved, at that point we used CUDA 7, that was the latest CUDA, and CUDA version 4, and it was 10 times energy efficient compared to a desktop CPU. And then last year, a little over 6 months ago, we just did a software upgrade. No hardware change, the same module, but we've added Tensor RT, moved to the next generation of CUDA, next generation of CUDA-NN, and added more capability without any change in hardware, just a software upgrade with double the AI performance. And then just a couple of months ago, we doubled the performance again by adding more capability. So the beauty of Jetson and Jetpack is that as we're continuously innovating with software capabilities and AI stacks, we are continuously upgrading this and providing to everybody in the ecosystem. So a factor of 4 improvement with the same underlying hardware. Now, Jetson has been adopted by many different vertical markets. And in this case, I'm showing you several intelligent machines, robots, if you will, that have adopted Jetson. And many of these are startups or established companies that have already announced products, shipping products in some cases, or doing trial runs with commercial devices. In agriculture, factory automation, you've seen the service robotics video prior to the keynote. Package delivery, who doesn't like package delivery? My wife loves package delivery. The other day she got 5 packages, so I think everybody likes package delivery. So many of these packages are now being delivered to our homes. Warehouses, as more and more of these packages are being delivered, you have to have big warehouses that are going to be monitored, inventory management, security robotics, submersibles, and last but not the least, the Jetson platform is being increasingly used in academia. And by academia, I don't just mean graduate schools or undergraduate universities. Many of the undergraduate universities and graduate universities worldwide are teaching AI classes using the Jetson platform, which is not surprising given that Jetson is the most highest performing edge platform for AI. But we're also seeing many high schools are using the Jetson platform for robotics. Now, there is approximately 4,000 worldwide high school robotic teams that participate in this contest every year called FIRST Robotics. And out of those 4,000 teams worldwide, already 500 teams started using Jetson in the last 12 months, and they go to the finals. So even the high school students now are able to take Jetson, immediately deploy in their robots, and do contests and deploy AI in these Jetson-based devices. So I'd like to show you a video of some of these commercial robots that are deployed. So can we run the video, please? Isn't that cool? So all those robots that you saw just have been enabled in the last little over a year or so. And amazing that these universities and startups and big companies are able to take the Jetson platform and quickly build a robot, and in some cases go to market already, or in some cases actually go to trials with end devices. That's how fast they're able to take advantage of the Jetson platform. Now, in addition to these customers, we've also created a partner ecosystem with Jetson. As I mentioned earlier, there are several tens of thousands of registered developers on Jetson, and many of them do not have the capability to build their own hardware. Some of them do not have the capability to build some of the software pieces. So what we have done is we've partnered with several companies, some of them are actually based here in Taiwan, that are building reference designs or carrier boards that basically house the Jetson module. And we have several of these partners that make different form factors. And likewise, we have several software and services companies that are able to provide many of these emerging companies with support in the software side. And of course, last but not the least is many of the universities are having teaching courses based on Jetson. So now I'd like to spend a little bit of time going a little bit deeper into some of these vertical markets in this Internet of Things. I'd like to start off with the so-called smart cities, or what we think of as AI cities in the future, not just smart, but intelligent cities. Now, an AI city is both a safe city and a smart city. As you all know, for any city to be smart, first of all, it needs to be safe. All citizens in a city must feel comfortable and it's a safe environment. And safety, or public safety, some people call it video surveillance, that it is an existing market, and like things like video surveillance, law enforcement, and forensics help keep cities safe. And then once you build a safe city, on top of that, you can add the efficiency. For example, if you look at all the cities in the world, there's millions of cameras in every city that are deployed. These are capturing video 24/7. So using AI on that video data and what we call doing intelligent video analytics, we can transform raw video that is anonymized into valuable insight. So that is what an AI city is. So many cameras are already installed today, and many, many more cameras are going to be coming online in the next few years. By 2020, it is expected that all the cities in the world will have approximately 1 billion cameras in operation 24/7. That is a lot of data. Now, if you want to deploy humans to watch that video and make sense out of it, basically it will take 3 billion human beings working 8 hours a day to watch this video. And of course, it is a very boring task to see all these videos, and obviously humans are going to miss many of the critical things that happen. So the way to solve this is you have to use AI as the right solution for it. Now, video analytics is not a new concept. For the last 10 years or so, many companies have been trying to process this massive amounts of video using video analytics, but using traditional methods. But the problem with the traditional methods always has been that the accuracy is nowhere close to a human. You cannot really trust the result because of varying conditions. There's different lighting conditions. There is different weather conditions. The cameras are calibrated differently, such that the accuracy is never close to what is required to trust that result. And as many of you know, using AI for image classification as of 2 years ago in 2015, AI-trained neural networks have exceeded human being. So now, suddenly we have a tool for image recognition, image classification. Using AI, we have a chance of solving this problem. These billions of video frames that are coming in every day, we can solve that using AI. Now, in order to create an AI city, it is an end-to-end problem. It's a problem at the edge, it's a problem that needs to be solved in the cloud, and it's also a problem that needs to be solved on-premise or a gateway device. Imagine this is type A city. Now, in the case of, imagine a parking lot, or imagine a police officer that has a body camera. And in that case, you're doing the processing at the edge, in the camera, either in the camera of the police officer or the camera that is at the parking lot entrance that is looking at license plates and figuring out who paid the toll and who did not pay the toll. So that's one example where an AI city needs AI at the edge on the device. But then imagine an airport. Imagine Taoyuan Airport. You've got hundreds of cameras in the airport. It is not enough to have AI in the camera alone, because in such a scenario, it is important to understand what's happening across cameras, because a camera viewpoint is only fixed. It is important to know what's happening in this direction. It's important to know what's happening somewhere close by in the airport, likewise in this direction. So it's important both in space and time to understand the scene. So in order to do that processing, it is not enough to do all this AI in the edge. You actually need to do some processing, combine all these camera streams. Typically, it ends up being a server, on-premise server, that is deployed in the airport. All the camera streams come in there, and the server can look at a zoomed-out scenario and look at all these streams and make intelligent decisions. Now take it one step further. Say you want to optimize the traffic flow in type A city. Now, which roads are busy with traffic? Is an accident maybe? And then you want to reroute traffic in a different street. For that, it is not anymore about on-premises. You need to have almost a city view, which means important pieces of data needs to be sent into the cloud. So in order to create an AI city, you need processing at the edge, on-premise, and in the cloud. So it's going to be a hybrid architecture from cameras, network video recorders, to servers, to cloud processing. And for this, we've recently announced in GTC a little over a couple of weeks ago the NVIDIA Metropolis platform for AI cities. This is an edge-to-cloud AI platform. So as I mentioned earlier, you have the training in the cloud, typically on a DGX, or maybe use a HGX in one of the cloud service providers. And if you're doing any inferencing in the cloud, you use the same GPU. And then when it comes to the inferencing, it's either deployed in the camera, or it could be deployed in a video recorder, or so-called network video recorder, or in a server. And we have the Tesla product and the Jetson product. And we've basically unified this into a singular platform with the same software stack across everything from the edge to cloud to enable intelligent video analytics to solve this AI city, which is both safe city and smart city, using raw video data, anonymizing it, and transforming that into real, valuable insight using artificial intelligence. Now, the NVIDIA AI City platform has been adopted by many, many partners. Actually, over 50 partners have already announced products, and many of them already have deployed products commercially in the last 12 months. So you can again see the trend as to how fast this AI revolution is happening right in front of us. In just 12 months, over 50 partners in the video, surveillance, public safety, and smart city world have deployed products using NVIDIA GPU deep learning. And these are some of the examples. And you can see the reason why this many companies have quickly moved to GPU deep learning. Obviously, one thing is accuracy. Deep learning is much more accurate than traditional methods. Second thing is it's incredibly fast and it's scalable because you can put some AI in the camera. If you want to scale to more video streams, you put it in a recorder. If you want to scale to hundreds of streams, you can put it in a server. If you want to scale to thousands of streams, you put it in the data center. But it's the same GPU architecture that scales from edge to cloud. So there are many of these partners all over the world, in both Asia, Western Europe, and US and many other places. Everywhere you see that deep learning is being adopted in this. And here are some of the AI city partners. As I mentioned, this is just a select list. Over 50 of them are adopted, and a couple of them actually are from Taiwan. And if you have time later in the day, you should actually go and see their demonstrations. Ambo CV and Irenyun are Taiwan companies actually using deep learning in the cloud using NVIDIA GPU, solving critical video analytic problems. And we actually have a video for you to share that shows you some of these partners in action. Can you please run the video? So now, AI factories for manufacturing and industrial automation. One of the most popular applications that is actually done here in Taiwan, because it's one of the manufacturing centers of the world, is when you're building phones, when you're building laptops and tablets and all this very cool electronic products, automated optical inspection is actually an extremely important step. Today, it's mostly done by humans, and it takes approximately 3 minutes for a human being to do a great job at looking at a phone, for example, and looking for all the defects. Now, using the power of artificial intelligence, deploy AI into a robot. In this example, Fanuc out of Japan has basically done this prototype, which is, of course, extremely configurable with respect to which defects are allowed, which defects are not. It's really a question of, what is the tolerance limit. And using deep learning, they're able to demonstrate this, do this at the same or better accuracy than a human being, and do it 10 times faster. So this really will enable the manufacturing throughput to go much, much faster than where we are today. We actually have a video from Fanuc that you'd like to look at this in happening live. Can we see that, please? Agriculture. Only 1/3 of the world's land that is fit for agriculture is today used for agriculture. Still, there's 2/3 of the land that's not used for agriculture, number one. Number two, the world's population is approximately 7.5 billion today, and it's predicted that by 2050, it's going to approach almost 10 billion. A lot more human beings are going to be coming into the world. And improving the productivity of agriculture, improving the yield is extremely important. And also, decreasing the amount of chemicals and pesticides is also very important. And deep learning and AI is being applied to this agriculture industry to solve both these problems, increasing yield and decreasing the amount of pesticides or chemicals that you have. And Blue River is a startup company out of California. Basically, they've built this is a standard tractor, but basically what you see in the tractor is you see in each of those, there's 18 of those in the line, each of them has a Jetson TX2 inside that. Okay, and each Jetson TX2 is basically analyzing, there's two cameras, one backward-looking, one forward-looking, and it's basically looking for lettuces and it's looking at weeds and figuring out real-time where it should deploy the chemical or the pesticide to kill the weeds. Today, without that kind of technology, it's typically just sprayed across, and that actually takes up a lot more pesticide, unnecessary pesticide. So with this, using deep learning technology, Blue River is able to increase the yield by 10%, but more importantly, reduce the chemicals by 10 times, reduce it by 90%. Many of us start buying organic because we don't want to have pesticides or chemicals to our food, and if you're able to reduce it by 90%, that I think is an enormous value that's being brought here. We actually have a video of them doing that process. Can we run the video, please? Okay, one more thing that I want to talk about in the Internet of Things is automotive. Of course, you've seen the BB8 self-driving car demonstration earlier in the keynote, and that's using our Drive PX2 platform. And recently, we've announced the next generation processor for autonomous machines called Xavier, and this is intended for the next generation of self-driving cars. In this Xavier provides 30 deep learning TOPS, tera operations per second, at 30 watts. That's a lot of processing power. So if you think about it, the Jetson TX2 that I just showed you earlier is a little over one teraflop. This one is 30 times faster compared to the Jetson TX2, but it's only 3 times higher power. So we are again increasing the energy efficiency by a factor of 10. Going to the next generation. And the way we are able to achieve that capability of deep learning AI performance is we went with a hybrid processing architecture in Xavier. First of all, we have powerful CPUs doing the CPU tasks, serial tasks, and then we have the next generation Volta GPU that has all the deep learning acceleration. And out of the 30 teraops, the GPU provides 20 teraops. So 2/3 of the performance comes from GPU. But for the additional 10 teraops, we've added a specialized engine for deep learning inferencing. It is called DLA, or Deep Learning Accelerator. And the Xavier SoC has 2 copies of this DLA. And this is each DLA is capable of 5 tera operations, deep learning operations per second. And Jensen, a couple of weeks ago at the GTC keynote, we announced that the DLA, we are open sourcing the DLA. The DLA has been built by NVIDIA using the many years of experience we have developed in artificial intelligence and deep learning, not only at the hardware or IP or processor level, but also at the software level, the algorithms, the system, the complete stack end-to-end. We have a lot of expertise that we have built in the last several years, and we've taken that capability and designed the deep learning accelerator. And now we decided to open source it so that anybody can take the deep learning accelerator, use it as is, change it any way you like, maybe increase performance, or maybe for cost reasons, make it smaller, depending on the product that you want to deploy, and whether if you want to put it in, not every intelligent device or an autonomous machine needs tens of tera operations per second. Some of them just need maybe a few hundred giga operations per second. Maybe something needs just 1 tera operation per second. So you can scale the DLA up or down. And this is NVIDIA's, we want to expand the scope of AI. We want to increase the adoption of AI. So this is one of the initiatives that we took, is the best technology that NVIDIA developed, make it available for anybody. So if you're a chip maker, if you're a system maker, you can use the DLA in your product and deploy your product. So this is going to be available as early access just in a couple of months in July, and general release is going to be available in September. So you can take the DLA as is or modify it as you see fit, and turbocharge, the development of AI systems. So in summary, IoT, many different vertical markets. AI is going to be in every IoT device in the future. There is no question about it. And we've created the Jetson platform for markets and segments of markets where you need high amount of processing power in a very small size and very low power. Now, some of those markets, Jetson is too much. For a very basic camera, Jetson is an overkill. So for those kind of markets, we have created the deep learning accelerator, and we have open sourced it. So you would be able to turbocharge and take advantage of the NVIDIA AI computing ecosystem. With that, I'd like to thank you for your time and coming here today.
Thanks, Deepu. That was a great introduction to IoT and AI and IoT. Deepu talked a little bit about AI and IoT for healthcare and life sciences. And our next speaker is Ethan Tu of Taiwan AI Labs. He's got a great history in AI and also as a developer here in Taiwan. He founded 2 companies in the 90s, PTT and then Yam.com. And then, as all great software developers tend to do at some point in their career, in 2006, he went and he joined Microsoft. At Microsoft, he was a senior researcher and developer in their Internet Services Center in Redmond. And then he went on to work on the team in Microsoft AI Labs that founded Cortana. And Cortana is, of course, all of that was developed using GPU deep learning on the training side. And recently, just in February of this year, he came back to Taiwan and started the Taiwan AI Lab. And so to tell you a little bit more about what he's doing there, welcome, Ethan.
Thank you. Thank you for the introduction. It's a very well-organized event, and I am very honored that I am the only guest speaker here today in NVIDIA's event. Good afternoon, Taiwan. So I think today I'm going to tell you about the story. This is my slide. That's fine. Can you get my slide? That's fine. Let's talk. I think today I'm going to give you a story. It's not about myself. I can tell you the story about myself, but I think the story is about the people in Taiwan, how we can organize together to achieve the TADIS text together. So here in Taiwan, we call it, some people say it's a 乡民文化, it's a culture of villager. That means whenever there's a hard problem we want to attack, then we will try to organize all the expertise together to solve the problem. And that went pretty well in actually PTT is not a company, it's the nonprofit organization. But if you think about PTT, we founded 22 years ago. Until today, it's not, so when you think about, people say I'm the founder of PTT, then I must achieve a lot of things. This is not I achieve a lot of things of PTT. It's all you guys here. You use your own innovation, use your own idea, and use your own creativity, and try to attack the most complicated problem in the world, in this society, or in this country, in this culture. So Inspired by these ideas, so after I work in Taiwan, and in 2003 I joined NIH, that's the National Institute of Health, and we work on the Human Genome Research Institute. So at that time, that's the history in the human that we first defined the human genome, and we know how to sequence it. Although we know how to sequence it, but we don't understand it at all. So in the very beginning, we do some research like how it associates with the cancer and how it associates. Okay, I see my slide. Okay. So how we associate the cancer with a particular genome. And I think it spent more than 10 years. NIH spent like $5 billion just to sequence one human's genome. At that time, we don't know what we can do with this human genome, but we know it must be some secret there. That time we start to see the result coming. So I will tell you about how we do the human genome later on. And after I joined Microsoft, I think Microsoft is such a great company that it gave me a lot of freedom to think about things and think about how we do things differently. Hello? Okay, so fortunately, I think I was in one of the most interesting lab in the NSA that is funded by Haitian, that is Internet Service Research Center. So at that time, the goal we want to achieve is we try to analyze all the data. We try to collect all the data from the world and try to know the quality of the search engine and how we can improve the search engine, make it better. Then later on, I joined Bing, and in Bing, we do the dynamic crawler. That means how can you get the information outside the world efficiently and dynamically. It's not like a static HTTP page, but it is the browser render result, and we try to understand it. Then we index the result based on our understanding. Then I think in around 2013, I think the biggest change in my mind is I joined a very interesting project that's called Cortana. And at the very beginning, Cortana is also a very small project. It's kind of the side project other than Windows or Bing. It's only a kind of innovation, a startup inside Microsoft. Then we start up in a small team, small group, and we put into our idea imagination. Then we deliver our first version of Cortana on Windows. And the second year, we deliver the Cortana the personal assistant. So the imagination we have is that we want to give everyone in the world a personal assistant. And this personal assistant will understand the person. So think about when we do Bing, it's a search engine. We understand the whole world. Then we do a personal assistant, understand the person. Then if a personal assistant can understand the person pretty well, connect to the world knowledge, then that means we can serve the person pretty well. Honestly speaking, doing a personal assistant is a very tough challenge, including the expertise of the speech, of the language understanding, and all kinds of the problems we solve. Fortunately, because of the data in Microsoft, we accumulate a large amount of data. Because of the engineering quality, inside Microsoft, we have such a great research institute. Try to improve our speech recognition, try to improve our language understanding, and try to improve our user experience phenomenon. In the end, we deliver actually Cortana in a very fast pace. So as you can see, like 2016, last year, a Microsoft Build event, when we announced Cortana as the central of the agent for the whole Microsoft AI and the intelligence. It became phenomenal. So at that time, we present three ideas. The first of all is conversation will be the next user interface. That means in the future, when we work with the machine, conversation just like a human is the most natural way to work with machine. The second thing is bots will be the next app. I will talk about bots later. That means when you work with a machine, today we use a touch screen, we use a phone filling, and we do the intonation, we use keyboard. That is not the way we should use machine. In the future, when you work with a machine, you should communicate just like a human. So for every expertise of the application, that will become individual bots. And the third thing is artificial intelligence, that's what we call AI, will be infusing all these experience. If you don't have AI, then you just become another stupid bot. And if that's a stupid bot, then people will not use it. You just convert the phone filling from a touch screen interface into a conversational interface. And now that is totally not workable. So the third element you need to do is you need to ensure everything is with artificial intelligence. You need to help user to understand user in order to achieve more and do more. And that part actually is not a simple problem either. So you can see like after we announced the bot strategy in last year, the Build event, the Facebook also announced their messenger bot. And also Google also announced the Arrow as their assistant across the platform. I think that's familiar. You can see all the technical leader is doing the same thing. We try to change the way we communicate with the machines. And we will to put the best people. Like in Microsoft in 2016, we organized a group of people that is more than 6,000. I think at the beginning it's more than 5,000, 6,000. And currently I heard from Harry, it's more than 7,000 right now, the best engineering in the world with well-trained artificial intelligence experience and doing the best thing for the world. Okay, so then the next question is, all these big companies doing artificial intelligence, what can we do? So this is my observation from the industry. So when we do Cortana, for example, and we release Cortana, after we release, actually there's a lot of Cortana capabilities. So we integrate into a Microsoft Connected Service and the Cortana Intelligence Suite. That means all the enterprise, if they want to use the capability Cortana want, Cortana have, you can also purchase the service in the cloud, that's in Azure. But soon we found there's still a huge gap. So when we for example, if you see the picture I just saw on last page. So we went to the IoT event in Shenzhen, and we announced Cortana and also the package of Cortana Intelligence Suite and also the capability of connected service. However, you just find that the industry leader come to us, ask to me, okay, so if I purchase this Intelligence Suite, can I just plug it and voila, my bots can suddenly talk? It's not going to happen. That means the imagination of the tech leader company, the platform we deliver so far, is actually very great, very very fundamental, important. You don't need to redo your speech recognition, language understanding, for example. However, for a particular domain, for example, if you are an appliance maker, you want to make your appliance talk with you and work like a genius. That is not possible. You just buy a Microsoft Connected service and also this Cortana Suite. You can suddenly do this like this. No, you still need to have a lot of training and a lot of experience. That's also one reason I suddenly found the tech company, we provide such a great tools, such a great engineering ideas. However, fund the as today, it is also possible that all the experience we can deliver by AI, and we can use AI to beat people like AlphaGo beat the world champion as well. But if we want to use this technology to a certain domain, there's still a huge gap. So that's the reason I start to thinking, and at the same time, because my father is in Taiwan, so I'm thinking, so can we do something here, like what we did in PTT 22 years ago? We can have a group of people, have a lot of innovation, a lot of ideas, have a lot of different expertise. Then we work together to achieve the problem, to take down the problem with artificial intelligence sufficiently. So with this idea, I talked to the administrator of the science and the technology in Taiwan. And I also talked to the Tan Feng, I don't know his English name. So, and I also talked to the professors. Like I actually see some professors here in the National Taiwan Universities. And I found everyone is so excited that, oh, I just want to do it. Let's do it together. So last month, in April 27, we announced we want to fund Taiwan AI Lab. So that's the history. We put all the effort together, all the idea together, and from my imagination and from what we observed in Taiwan culture and the energy of Taiwan, and we want to put it together for the AI revolutions. So this is just a repeat what we have and a build event. So then people will ask me, what do you think? If you think about three most important things for teaming up a successful AI lab, what is the three most important innovation you want? The first one, of course, you need data. Data is everything at the beginning. If you don't have data, you can observe nothing. If you don't have data, there's nothing to do. So then some people will ask, okay, I'm a small company, I don't have data, what should I start? And other people might say, oh, I don't have data, then I need to write a crawler to crawl the whole internet like Microsoft or Google. I would say both answers are no. Don't do that. Do not write another crawler, and do not be scared that you don't have data, because you can always collect data. So here is a statistic. In today, as if today, in past 2 years, we have produced 90% of the data in the human history. That means before 2 years, only contribute to 10% of the data so far we have today. That was because of the smartphone revolution, the cloud revolution, and the industrial digitalization. Only 2 years, we produced 90% of the data from the human being. And you can already feel that the web data is already not the most important. You can ask yourself, when you want to look for something, in the past, you maybe open a browser and search for something. But today, most of the people, they just open an app. And those apps does not consume the data from the cloud. They just collect the data by themselves. So you can see how fast the data change. And it is similar to like in 1990s. I still remember when I do PTT, for example, and then we start some internet ideas. People will challenge me. You don't have data. What do you put on the internet for people to see? I have all the music license. I have all the content license. You don't have data. But today, if you are from Taiwan, you know how much data we produce on PTT every day. It becomes a domino. So don't worry about data. Worry about how to collect data and what kind of problem, what kind of data you need. So the statistics today, we have 2 billion mobile phones in the world right now. However, according to our a lot of the prediction, that by 2020, there will be 25 billion IoT device, smart device in the world, which means most of the data by 2020, you have not ever seen yet. So I can also forecast in 2020. At that time, when I gave a speak, I will tell you, in past 2 years, we already collect 90% of the data of human history. So the data collection is like exponential. Because the technology revolution also exponential. That's why we say the Moore's law. So stop worrying about data. Think about what data you need and collect it right now. And you can also think about the data you collect in the past will not necessarily help for AI. I can give this as an example. In 1990s, the people who can have data are the bookstores. They have books, have text. Are the movie makers. They have movies. They have CDs, movie DVDs. We have data, but those data is not very useful for on-demand browsing and on-demand watching. Therefore, we have YouTube. Therefore, we have Facebook. Therefore, we have all kinds of these internet new medias. The same thing will happen in AI revolution as well. The data you think about is available today, like the web data, the YouTube data, the web page data. It's not the best fit for AI. What are the best fit for AI? I can give you an example. When we say intelligence, what means intelligence? So when I come to this event for the speech, the people here see me, oh, you are Ethan. You are a speaker today. That's called intelligence. So what is not intelligence? So I come to here, speak, then some robots show up here. Okay, welcome. Please fill up your information. What is your name? Ethan. I should have input in Ethan name. Which Ethan? Is Ethan 2? Ethan name? Ethan blah, blah, blah? That is not intelligence. So why people here see me can instantly know, oh, you are Ethan, you are PTT. Why? Because you have all this surrounding information. You know I will come to this event. Maybe you did not see me before, but this person looks a little bit geeky. This person looks like have something to tell. So actually human brain is trained to get a have a lot of additional information that is not come out of the speech, not even come out of the image. So speech recognition is one thing, image recognition is one thing. That's a capability we must have in order to understand. However, it's not enough. The same thing for the industry. The same thing for everything. Whenever you think about the data, you are not collecting only video, audio, or text data at all. You are collecting all the information, not including your location. Like for the health device, you will collect your heartbeat. For your exercise, you will collect a lot of that additional information as much as possible. For the autonomous driving, for example, every second you will collect gigabits of data. And you will need to define which data you want to save, which data you want to process, and which data you want to send to cloud. So those are the data I'm talking about right now. So you can imagine 2 years after now, 3 years after now, the data on the internet become a minor. The data collected from the IoT become a major, become the majority. So start worry about data right now. Think about how to do the data innovation. And what is data innovation is, observe the problem you have, find the data you need. Okay, the second thing, remember I said, if I tell you 3 innovations we need to have in order to cooperate with this AI resolution. The second thing we need is an algorithm. 1 million AlphaGo can beat a human. 1 million Microsoft speech can achieve better than human speech recognition. 1 million our ImageNet can recognize image better than human. That is because of the algorithm. And one part of the most discussed algorithm right now for machine learning is deep learning. I would say deep learning changed the way we think. However, neural network is not the new thing why deep learning become capable today. That is 2 fundamental changes. One is like a lot of the GPU computing revolution actually gave us a big enough computing power, and also the data we collect, accumulate from the internet, from the search engine, is able to train our machine to become better. And the cloud computing also help us to improve our computing power on the cloud, so we can attack huge amount of data at the same time. So the second thing we can consider about is algorithm. So when you think about algorithm, you try to improve, find the area you are most interested in, then you have a best knowledge. But I will encourage everyone, do not go into the same area we already saw. For example, AlphaGo already beat a human champion. I see a lot of AlphaGo B, AlphaGo C, AlphaGo copycats, but that's not useful. Find a new problem to solve. And the new problem is always just next to you, so find it. And the third thing for the AI revolution, I think is very, very important, is fun experience. And I will say the experience you see today is definitely not the best experience in the future. So it is like an internet revolution. The experience have a traditional corporate deliver. It's not the best experience on the internet. But it will come with a fast iteration. That means for the AI revolution, it will be the same, and it will go faster. Because we have a good tools. Right now, we have a very great cloud computation power, and we have a lot of good experiment platform. So we can try our idea one by one. Not like before. Before, if you want to try something online, then you need to buy a server, and then try to install the OS, then try to learn how to run the Apache and so on. But right now you don't need it, because right now you can go to the AWS, Azure, or maybe the NVIDIA cloud service. Depends on what you need. Then voila, you can run, you can have a system in the cloud, and it's run forever. Like right now, actually, you know PTT has 3 sites. One of the PTT is cloud, that is PTT3. And actually, that was the site I don't need care most, because it just run. It never turn off. So try to utilize what we have and try the experience one by one. And this slide show you after April 27, there are a lot of people discuss with me about what they can do and what we can work together for the AI projects in Taiwan. So we have like a city government in Taiwan think about the smart city ideas, and we also have some very reputable industry leader think about automatic driving, and we also have a very capable industry doing the robotic research, want to do the robots with us. This is the beauty of Taiwan, because it's a very small place, but you have all kinds of experts, and they are most of them are the best in the world. If you have any IoT idea, you need a sensor for sensing, you can always find someone here. And even if they don't produce, you talk to them, they will produce one for you. And like NVIDIA chipset, work with Taiwan Semiconductor. If you want to really need to have some chipset that is specialized for sensing, you can also find a manufacturer, ODM, OEM here. That's the beauty of Taiwan. And at the same time, we have the best software engineer. So that is one thing I also feel very, very amazed is after April 27, so today is just after a month. Actually, we are fully hired. I just sold out all the positions I have. So after we announced, every week I got thousands of resumes. So the resumes are from three different places. One is like in the technical leader corporate in Taiwan. They have a lot of experience on the hardware, the OEM, ODM industry. And they are also new students. They just graduated from school. Deep learning is a new area. However, in Taiwan, we have tens of good professors teaching deep learning, and we produce a lot of very great talents in Taiwan. So suddenly I got a lot of intern requests. Oh, I want to be an intern in AI lab. And I also got a lot. And for in the intern project I see, I am quite amazed that for some problem like I know there are a lot of people saying, oh, AI cannot cannot be creative, and AI cannot feel the sentiment. However, I always see the student try to solve those questions, just like their home project or their pet project. That means you can see the creativity of this new graduate student here in Taiwan. They really think a lot of what we can do in AI. It's even more than me. That's the reason why I come here. I say, I'm not telling a story about myself. I'm telling a story about Taiwan and all these great people, great ideas. And the third source of the resume is about 30% is outside Taiwan. We have resumes from Israel. We have resume. Israel is also a small place with very good talent. And we have resume from United Kingdom. And the guys in the DMI group, I cannot tell who is him. And also we have resume from the Google office in Mountain View. We have all kinds of resume, and also some resume itself, like Amazon, those technical leaders. So from the top 5 technical leaders, I can see all the resumes, and now I can see all the resumes from the top industry leaders in Taiwan. So I'm quite amazed. Like we have such a good, we have such good candidate quality. I would say, if you hire good talent in Taiwan, the quality here is very, very high compared to the quality the candidate I hire in other places. So we talk about 3 big innovation we should attack. One is the data, one is algorithm, and the third, we need to find the area of experience. So I would like to drill into one experience. It's probably not the best match for my background because I'm in NIH for only 3 years on genome research. A lot of people maybe here they are medical doctors, can speak better than me. So when we team up the AI for healthcare and bioinformatics team, I actually talked to the professor, say, maybe this talk you should give the talk for the NVIDIA about how we can use AI for the bioinformatics and the healthcare. The interesting the response I got is, no, we are 我们是乡民 we are volunteer. We don't want to stand on the front. So I gave you material, you just talk about it. So that's also one interesting here I found is people have a great knowledge. People is capable to do a lot of things, and people is very, very innovative. However, they are quite humble. They don't want to stand at the front line. That is actually the way we talk in BBS. Say 我们不想跨到线的前面。So and the professor just told me, I think you are the better one to present because you don't have enough knowledge. That means the speech you give, people will easier to understand. Okay. So here's a problem we were thinking about is a lot of people heard about the real disease. They might think about, oh, the real disease is not impacting me because it sounds real. However, because there are a lot of different kinds of rare disease, and so in total, it still impact a lot of family, impact a lot of parents. For example, the first, the deep genetic founder, the reason he found deep genetic is because the baby he delivered is with a real disease. And the genome sequencing just tell nothing according to the current genome experts. So one of the 17 people will suffer from a rare disease. That's actually quite a lot. And most of the rare disease is not diagnosed because the cases are too rare, and usually the doctor don't know what to do. And because of the current regulation of the medical systems, usually when we want to put into a treatment, usually there will be a lot of prone diagnosis that is helping for your new medicine or new treatment method. But because the rare disease is real, so it's kind of hard for them to have a systematic way to diagnose in a molecular base. So only 25% of rare disease will finally diagnosed in a molecular base. And most of the kids, they die before the age of 5. This is a very high rate, it's 30%. For a rare disease, so far, most of them are related to the genetic problem. So 80% of rare diseases contribute to the genetic problem. Then we think about how we can improve. So, of course, other than the genetic way, like NVIDIA, we already have some app like using the face. This is also an application of AI. Use the image recognition approach to diagnose if the child have a Down syndrome. But I would like to promote is the genome approach. So most of the rare disease we can observe from is genome expression. Why we don't look into genome and try to solve it? And in the morning, you already heard that in the CPU world, there's a most role for CPU. Every couple of years, we'll have a couple percentage of the performance improvement. At the same time, the most role also apply on the cost of the genome sequencing. So in the past, you can think about NIH just spent $5 billion to sequence one person's genomes. But right now, per person sequencing is already below 1,000 US dollars, which means, and I know a lot of you, if you have baby, when you deliver a baby, people will ask, some people in the hospital will ask you, do you want to store their stem cells? And the storing stem cells cost is about 3,000 US dollars. But right now, if you want to sequence a human's genome, the cost is below 1,000 US dollars. And if you want to sequence the family's genome, it's about 5,000 US dollars. And from the genome, you can actually find a lot of information. And this is a core expression of the genome, which means at a very, very early days, like in 1998, we don't know what genome can do. At that time, we found out if a genome have a similar functionality, they will have a similar expression. So this is a distribution of the expression, but I will not go into the detail here. And this is, so after we found genome have a similar expression for a similar functionality, then the interesting part is how we can link genotype to the phenotype. So what does phenotype mean? Phenotype means how it appear in person. From outside, you look into a person. And genotype means how we look into the genome. So here you can see as early as 1999. At that time, we used microarray. We already see the linkage between the genotype and the phenotype. That means genome can already tell us something about the human beings. But what is the problem? The problem is genome is just like an alien language. It tells you a lot, but you just don't understand. What does it mean? So if you want to use a computer science way to understand genome problem, so this is the way I would say. So every human has 2 sets of chromosomes, and each set contains 3 billion base pairs, which means 2 pairs of chromosomes will contribute 6 billion base pairs. And if you think genome is a language, or the human body tell you something, if you speak in a normal person's way, like every day a person will speak about 20,000 words. 6 billion means you need to speak 800 years. That's a huge amount of data inside one person's body. If you consider only 1 pair, in 1 set instead of 2 sets of the pairs, the base pairs, that is still 400 years. So there must be some way. So when we want to understand a new language, I try to describe this speech recognition, language understanding way. But maybe it's not the different way from the biomedical person think about this problem. But I would like to use computer science the way to think about this problem. So if you think about proteins, so why people? So let me give some background about how genome works. So everyone has 2 sets of 23 chromosomes, and those chromosomes contains DNAs. Then the DNA sequence will produce messenger RNA, and those RNA is a way to produce the protein. And because the different type of protein is produced, it will impact our human body function differently. So if you look into the protein sequence, actually, you can also see a language of protein sequence. Although we don't understand, but you can see so our scientists already know this protein actually they are working for the same thing. And if you see the sequence, they have some kind of similarities. They all have C, G, G in a certain pattern. So that is like when we look into aliens' language, we don't know how to do it. The first thing is, okay, if this sentence will introduce this, then this sentence also introduce this, then we put all the sentences together and compare what are the sentence and what are the difference. So this is the way we first try to analyze the protein sequence and also the genome sequence. And if we use the biological structure to describe, so there's a way to describe. However, I would like to avoid use biological structure because in this way, it's harder to solve in a computer science way, so I will use the above one. And then there's another way we reduce the problem set. Because every human have a 3 billion, every set have a 3 billion base pair. That's a huge amount of data. So, but most of the people, the genome are mostly the same with some modification. So in the bioinformation, in the genome research, we usually have a reference genome compared with your genome. Then we can, for example, there's a human genome 38, HG38, the human genome reference. Then you can just know what are the differences of your genome. However, it's still a lot. That means so based on the there's a company called Human Longevity. So they do 10,000 human genome sequencing. They found within these 10,000 human genome sequences, there's still every human genome they newly sequenced will carry about average 0.7 megabytes sequence that is not found. And a lot of them, averaging about 8.5 normal variants is found in newly sequenced genome. And there's another effort in Taiwan. So like in 2015, maybe some of you already heard about Taiwan Biobank. So Taiwan Biobank is a government-funded. I heard that they have funded of $9 billion Taiwan dollars for the Taiwan biobanks, and try to collect all the information, start from the beginning. So if we analyze the data in Taiwan biobank, so the average variance for each person in Taiwan biobank is about 1.7 million. Then you may ask why we want to look into variant of genome. Because the variance of the genome will impact, like what I said, the produce of the protein. But not all the variance is matter. Because some variants just like so TFBS names after transcription factor binding site. So transcription is the process that genome transfer to messaging DNA. And if it fails, it will not produce the right protein. So this is activation. So it's like a lock. If you have this transition factor, then you can turn on these proteins produced. If you don't, then the proteins, producing of the protein might be in problem. So, and also the transition factor binding site have a pattern. Here we call motif. So motif is like a like a lock. We can define if this genome sequencing change will impact the transcription factor. And that will become one of the important things hereafter. So there are a couple of research in Taiwan is researching about So if we think about this transcription factor, it's about how DNA produce protein. and if we think about the real disease caused by the DNA sequencing, so there are a couple interactions, including from DNA to RNA, RNA to protein, and protein to protein, maybe protein to DNA, protein to RNA. But when you think about the transition factor binding site, it's just like only one set of the problem. So, because we know the transcription filter, then we can use this transcription filter, the variance, and we try to annotate what is the impact of the variant. So those are the basics of the genome research. Maybe I'm not the best one to tell you the basic, but it will help you to think about the problem hereafter. So in this way, we go back to think about how we can diagnose the patient with a real disease based on the genome expression. The question will become, given the whole genome sequencing of a person, can we answer why he is sick? So this is a problem. Of course, it's based on the assumption that it's a genome problem caused this disease. So there are very earlier study about genome-wise association study. That means given the base variant of the genome, can we find the association between the variants of the genome to the disease, the phenotype? However, if you think about the way it implement in this way, it's more like an expert system we used for the AI before. That is a little bit heuristic than the rule-based. That basically just lay out the whole genome, the genome sequence. And if those people have the same phenotype, we can see which variants of the genome is significant enough. However, this approach is not very useful because it can be impaired by a lot of matters. For example, what if the variance is the phenotype is impaired by multiple variants? And what if the precision of genome is very important? Then what if the precision is not mattered, but the binding size pattern is mattered? So in order to have better result, so in Taiwan we also very early we also have some idea building a deep neural network to understand. So this is done by a professor in National Taiwan University. So how we can find use a deep learning approach to find the DNA binding associated with. And you can think about this will become one of the components for the whole deep learning structure we want, find the genotype to phenotype. And we will need to have all these small components together, find the genome, find DNA to RNA, find the RNA to protein, find the protein to protein, all kinds of different possible interaction in the human body we put together for the hidden layers, then we can construct the whole structure. So after we think about all this, so the diagnosis process for real disease will be like this. So first, of course, the patient we need to sequence. And we have Taiwan Biobank have funded. We also have people know how to do the sequencing. Then we can do the sequencing. Then after the sequencing, there will be a variant cloning. That means finding the variant genome, finding the variant pairs in your body. So there will be different types of the variants, like you have insertion, deletion of the more complicated variant. Then after we have a variant annotation, then we can put into the neural network. The neural network design will just like we said. So the input will be the genome sequence. The output will be the phenotype. The inside, we will put into the different components, the interaction between the genome, RNA to protein, protein to protein, all those interaction we can put in together. And very interesting, so I don't know if you hear about the genome editing. So I think in 2014, sorry. So there's a paper saying that it is possible to do the genome editing, which means if this process works, we can know the problem of the genome. And if we know the problem of the genome, we can possibly edit the human genome in order to cure his disease. And it can also use for the other way. For example, if we say some genome has problem, we can also think about how we change the genome, then we put into a system again to see if that change will help to cure this patient. And that, in Alabama, we call it precision medicine. That means the treatment is precise. You treat this patient before you feel confidence. You don't treat this patient. So in the past, it's like, I try this drug for you, then that drug you until you are cured. However, the precision medicine means before I give you this drug, I have some simulation to see if that will cure your disease. And 2 years ago, so deep learning just boosted in 2012. And 2 years ago, we already see the first deep learning paper using for the genome research. So the basic approach you can also, so this is from the paper. So you can also see you have a similar idea that first of all, we calculate the motif and use this motif, put it together into multi-level hidden layer, and then use a feedback loop to update and make the network better. So you can already see the genome study is applying deep learning is taking off. And you can see the cost of the genome sequencing is already dropped. And you can see we have all kinds of expertise here in Taiwan. We have very good professors in Taiwan. We have very good hospital in Taiwan. And we have Taiwan Biobank. And we have all this good engineering, understand how to do the deep learning. Then we can put it together to think about how we can solve the real disease together. So that is in this principle. So you can see within 1 month after AI Lab funded, we have a group of people think about genome diagnosis together. We actually already have doctor commit. We have a professor commit. They actually do it just want to solve the problem. They think it is a great challenge they want to solve, and they think they feel fun and feel they accomplish something. That is actually the thing we want to drive in Taiwan. Actually, it's not we drive; it's we want promote in Taiwan. So we have good fundamental infrastructure. We have such good talent, and we have some good facilities like Taiwan Biobank, and we have like a national insurance. Taiwan Jinbao have a lot of data. How we can put this all together? Of course, there will also be some legal restriction or privacy concern, but those kind of issues, we can try to solve it together. And we really do something that will benefit to human future in the genome studies. And here's the history of the genome research. You can see as I just mentioned. So I think the NIH spent a lot of money. That's a very various stage. Huge amount of money is already invested by the U.S. governments. And later on, right now, I think it's almost the time. We should go in, use our deep learning approach, sequence all the people's genome in Taiwan, and try to find something interesting out of it. And I feel this is a very interesting project, so I also welcome if you are interested in participate in this human genome research. You can also contact us. So I will direct to the person right now is leading this project. So I give you a very brief summary for the genome genetic study. So you can see we teamed up the AI lab within 1 month, and we already have a very good progress on all areas and try to innovate. And we also have a good progress on hiring the good talents to do something meaningful. According to this genetic study project, what we can find is, first of all, still data. Don't worry about you don't have genome data right now. Think about genome sequencing cost is going down to about $1,000 per person. It's almost the time genome sequencing data is taking off. So, and don't worry about you don't have data, because if you look into Taiwan Biobank or the data publicly available in the world, there's already human genome data there. You can start doing something. If you have the background, you have the knowledge, and you really want to do something. And the second thing is you can see deep learning is such a good tool to simulate the area where we don't have good solution before. Because deep learning is a tool for us to abstract the problem, to simulate the interaction between the molecular bases. But we really don't know how to engineer the feature yet. That's no problem. We just define all these layers, and we put the data and put the result, and we see how it interacts with itself. And actually, once we train a deep learning model that works pretty well from end to end, we can reverse trace back to see which genome feature actually contribute to this disease. So deep learning for genome, I think, is a perfect match. But before you need to run the deep learning, you need to run the genome. One problem you need to solve is the computation. That is, you need to ensure that you have a good enough computation power, because genome sequencing is a big data problem. And you need to have a good enough computation power for calculate the training for the deep learning. And if the genome sequencing costs continues to drop, and the deep learning, computation, all these things continue taking off, according to the Moore's law, I can foresee and I can predict that in the next few years, the AI for the deep learning will become a real interesting domain and will be very, very important. I think there are a couple companies in the world that are trying to using the deep learning right now to solve the genome problem. However, because I'm from Microsoft, I'm from a software company, and I work on the PTT. from my point of view, become a very successful software company, especially for a new area. The first thing you need to do is very open. That means try not to hide everything you research. Try to work like an AI lab. We work together, we solve the problem together, and we publish the result together, and we share the result. Because genome problem is not the small problem, it's a huge problem. You need all kinds of expertise, and you need all kinds of different people. You need the expertise from the doctor. They have a close relation with the patient. They know the phenotype. You need to have a good engineer that works for deep learning, but at the same time, they need to know how the bioinformatic interactions are, how the genome interact with each other, with the proteins, all those stuff. So it's not like, oh, I only need one expertise, then I can achieve everything. No. So I will encourage that if we want to be success in the genome research, try to be open. Try to share your result. And try to do as much as you can, and we put it together to benefit the human future. So that's the last sentence we want to state, that is, okay, so AI Lab, we want to do a little initiative here, is using the deep learning for the genome research. And if you are interested in the genome research, you also have the expertise, then write an email to me, and I will refer you to the right person to contact with you. Then at the very end, but not least, I want to repeat what I said at the beginning. Stop worrying about the data. Data is very important. Data is everything for you to begin with, but don't worry about it. The thing you need is collect the data. Like Taiwan Biobank only just started in 2015. Don't worry about how many data it has. Try to be very focused on collecting new data, because all kinds of new data that are capable for AI, most of them are not collected here in the human history. So after 2 years, when we look back, we need all kinds of data. And embrace all IoT device. Try to collect all the data as much as you can through this IoT device. And be ready for your computation power. That's why I come here for the NVIDIA event, because I want to know the base architecture of NVIDIA. I want to know the future of the GPU computing. I want to know how I can apply my knowledge, my software mind, my big problems, using the most powerful computation machine platform, cloud system, to solve the problem with our talents. And the third thing is, so in this AI revolution, it's not like a one company and two company, Microsoft, Google thing. No. It's definitely the revolution for all the industry. So some people will say it's industry 4.0. Actually, I don't use those kind of terms, but I can understand every part in the industry, you can change it by AI. So if you are industry leader here, or you are in the industry leader in the world, try to think about how to innovate, how to change your industry in the way how humans thinking. If you can collect the data before other industry leaders, if you can analyze the data before other industry leaders, and you can make a result better before other industry leaders, then we'll become leading the next trend of AI revolution. So do it right now. And in the very last, I want to show you, actually there was a slide when when I show out how to use a genotype to predict the phenotype, the image of the human is actually also produced by AI. So this is a very interesting story. So in PTT, there was some article discussing a person, he is looking for some image and looks like this, so he drew a picture just like this. And suddenly another person online replied, okay, are you asking this person? So this another beautiful lady. So that's interesting. That's the interesting thing is that one person can just describe a sketch of the photo, and the other person can really find a photo out of this knowledge. According to this idea, two of our team members in our AI lab, they quickly come out the program, leveraging the most advanced technology. I think NVIDIA also showed this morning is imaging to imaging translation. That means you can. So in this translation, actually we train all kinds of human heads image, tell computer what human head looks like. Then, according to this human head, human face, we produce the line of the drawing. Then we train the AI. If you see this kind of drawing, then produce this kind of image of the human face, then it works pretty well. So any drawing you draw, it will produce a human head. It's just like a real human. And then we also apply the style transfer, the recent paper in the AI. So not only produce a human head, you can, according to this head, you can add all kinds of artist style. And it worked perfectly, and it's actually running runtime. So we use an NVIDIA GPU put together as a small server and test it. So you can at the time you draw, the image will change according to what you draw. So you can imagine this kind of capability. We can use it like for the police officer. If someone say something got stolen, you want to describe someone, looks like he can also draw this picture and produce a face. And you can also use for the artist. So if you want to produce an AI artist, you want to create an AI artist, you can create any kind of a human based on the description human describe, then you can do it. So I will encourage everyone. So this is just like a small test. The reason I told this is find the idea we have, and the developer put into action to the result. It's only a couple of days. You cannot imagine that this 2 years ago. So for all kinds of AI application, AI revolution, it will run at this speed, and the speed it will be going faster and faster. So participate in right now. Join us right now. Join us to leverage all the tools, all of your knowledge for the human beings, for a great future. Thank you, everyone. Okay.
So that was a great presentation, Ethan, and I have to say that the concept of AI in medical or genomics is especially fascinating to me. My son just graduated from university with an undergraduate degree in data science and computer science, and my daughter is just graduating as a pediatrician this coming Friday. So on the rare occasion when I have them both over for dinner, my wife is very upset because the conversation was very much about like you had. But you mentioned some interesting things that, you had 1,000 resumes, but this really leads into sort of the next topic of how do you get started. There's many people here that are at startups maybe or big companies in Taiwan and want to hire people. How do they go about, is it best, do you think, to go off and hire, new students out of universities, or should you go and look for some particular profile?
So from my point of view, when I look into the resume, I will require both. However, from my point of view, because AI is such a new thing, so if someone come to me and say, oh, I'm an AI expert for 30 years, I say I don't care, because I know AI only take off in these 2 to 3 years. So from my point of view, if I say the composition of the experienced developer and the new graduate student, I would say both have good attribute. For example, the experienced developer, maybe they can come out of the architecture and write a fundamental program and know how to use a cloud service and how to run it into real business faster. However, for the creativity, I actually prefer hiring newly graduate students. And from what I know from the newly graduate student, I found actually the school in Taiwan actually give very good education. They are capable to think about the future, and they are really capable to really do something by hand. Yeah.
It's so true. I recently hired a new PhD graduate, and after he'd been on the job for several months, I met with him, and I said, well, how is it going? And he goes, well, my boss has me doing 2 different jobs. And I thought, oh no, I'm going to hear his complaint. And he goes, but, I just finished my PhD. I can do 2 jobs in my sleep. Can you give me some more work to do? So we had to get him a 3rd job. You also mentioned about the data, right? And that's an amazing thing to think that, 90% of the data will be new 2 years from now. And I think that there certainly are a lot of people that have been doing machine learning, right? Maybe for 13 years, right? But not really deep learning.
Right.
And often I think that is people that look at data as they knew it, right? Or data that existed in the machine learning space, where you basically, as a machine learning data scientist, you try to understand the data and then map that to a known algorithm. Whereas with deep learning, it's very different, right? And almost you have to forget everything that you did. And so what are some ways that you go about, or you've seen people, going about thinking of data in sort of different ways that are applicable for deep learning?
I would say, so for example, when I was in Microsoft, actually people thinking changes along with the new technology as well. So like in the beginning, we really do a lot of feature engineering, try to find a good feature and try to weight the feature and try to do the phase rank and so on and so forth. But we also found that in the deep learning, sometimes the people they do feature engineering pretty well doesn't necessarily train the data very well. So I would say, if you ask me, I would prefer I have both talent, because a lot of time we still need some feature engineering. But it's a little bit like you want to be a model or the coach. The coach is the coach for specialized things, and the model you you try to feed your
Yeah.
your daughter more information, but you let it grow naturally. Yeah.
Great. Well, thank you very much again for coming, and certainly wish you best of luck. I look forward to coming back here, in a couple months, and because, as you said, AI is moving so quickly, and seeing how many more resumes you've had for Taiwan AI Labs, and what some of your first results are. So, thank you very much.
Thank you. Thank you, everyone.
So in the next 45 minutes or so, I'm going to, let's go back here, talk about how to get started with AI. Again, whether you're still at university and you haven't taken your first data science class, or whether you're at a startup and trying to figure out how do you get started, or whether you're at a large established company. As Ethan talked about, and as you've heard about throughout the day, AI is really sweeping across all industries. And the way that I think about this is, again, goes back to Ethan's first point. He said, if you're going to do AI, what you need is data. And if you think about it, every industry has data, big data. And if they don't, they will have it in the next 2 years, right? 90%. And a lot of people think, in fact, the early successes in AI were in some of the consumer web companies, right? The Googles, the Facebooks, other big consumer web companies. And some people say, well, Google will have all the data, or Microsoft will have all the world's data, so I shouldn't be bothered even in trying to compete. But the reality of it is that your data is in all sorts of different systems, right? At NVIDIA, our manufacturing system, right? Jensen talked about how all those GeForce cards, so many of them were built here in Taiwan. That system doesn't exist inside a Google database. It sits in SAP, our manufacturing system. Mobile devices will generate data. And so, again, that's, I think, what is powering AI across so many different industries today. The other thing that I talked to Ethan about a little bit was just that idea of, AI is a new era of computing. And you have to do nothing more, and because I have a son who's now been in university for 4 years, is I distinctly remember when he went off to school 4 years ago, he and some of his high school friends came over, and they were talking, of course, computer science. And even 4 years ago, what they were all saying was, remember, 4 years ago is when Snapchat came out. So he came over for lunch with his friends, and he said, we're all going to go off to school, we're going to study computer science, and we're going to learn how to make mobile apps that run in the cloud, because we won't even have to buy a server or run on Azure or run on AWS. It'll be mobile, or run on our apps. Well, of course, today, right, and I spend a lot of time interviewing, maybe not looking at 1,000 resumes, but I look at a lot of resumes and do a lot of college interviewing today. And today, almost no one that I interview says, I want to go build mobile apps that will run in the cloud. Now, many AI apps will end up being mobile apps that run in the cloud. But I probably interviewed 100 college graduates in the last 6 months. And albeit it's a self-selecting audience because they're interviewing at NVIDIA, but every single one of them said, I want to work in data science, I want to work in AI, I want to work in deep learning. And that's what I always say. If you want to understand what the next trend in IT is, go to your local university, go to NTU and talk to some graduates or talk to some professors, because that's where the new technology is coming from. And so I think today, while AI is really about 5 years old, or at least the current application of deep neural networks, the big bang in AI starting in 2012, We've already seen it expand because of much of the work that's been done in universities. And in fact, it's because 5 years ago, in 2012, Geoffrey Hinton at University of Toronto, Andrew Ng, who at the time was at Stanford University and working on the Google Brain project. Those were some of the first professors that took the old 30, 40-year-old deep neural network algorithms and ran them on a GPU. And so that research work is what really started the modern world of AI. So if you want to get started, or if you are just getting started, stay close to the universities. Whether you're at the university for recruiting, whether you're at the university to get some good ideas for a startup, or whether you're there just talking to professors to get some help in research. Secondly, we've seen the core technology frameworks. Again, 5 years ago, there was not really any core frameworks. Caffe, about 4 years ago, came from the University of California at Berkeley, was developed there. Today, arguably, some of the leading frameworks come from some of the largest IT companies, directly or indirectly. Google, of course, supports TensorFlow and developed TensorFlow. Microsoft has their cognitive toolkit. Amazon didn't develop their own framework, but they've put their weight behind the MXNet framework. And again, many other frameworks as well. But to all these companies, you can bet that their framework that they're supporting is going to be what they want to make successful. Now, of course, Amazon Web Services wants to run all your TensorFlow apps, right? And Google Cloud wants to run your MXNet apps. But again, they're going to work hard to make sure that their strategic frameworks work best in their clouds. And again, today, you don't have to go, just as what my son talked about 4 years ago, but 4 years ago, it was very hard to find a GPU in the cloud. But because of the rise of deep learning and the popularity of deep learning, now all of the major clouds have GPUs in them available. You have the startups. In the NVIDIA Inception program for AI startups was only launched last August, less than 1 year old. And today we have over 1,200 startups in over $5 billion in funding. $5 billion, that's a lot of funding. And finally, in every industry, you have industry leaders, right, that are leading with AI, and you have others then that will follow. So I touched a little bit on this with Ethan when I talked about, traditional machine learning versus deep learning. So artificial intelligence is, of course, a broad, general field within computer science. And machine learning is a type of AI where you have a data scientist. The data scientist has a set of algorithms, and they map the data to those set of algorithms, often statistical based. And machine learning has been around for 10 to 15 years and is very good for certain types of problems. And it's good for the types of problems where the data scientist understands the data. But think about all of the things you've heard about in AI today, whether it's understanding or teaching a computer to paint a picture like Picasso, or to understand the difference between an ambulance and a tow truck, right? In the data of those, in the data that exists there, the data scientist typically didn't understand what the attributes that made one set of data different from another, or one object different from another. What the data scientists knew or came up with was the idea of what is the label on that data. And while there's new research going on today in so-called unsupervised training, almost all of the production deep neural network applications today are based on supervised training. Supervised training being you train the deep neural network by having labeled data that says this is an example of this type of data. So deep learning then is a breakthrough that lets you work on that basis. So how do you get started? First of all is identifying the problems you'd like to solve. And again, the data behind those problems. What data do you have access to? What data do you need to go off and get? Secondly, you need to think about what sort of people do you need? Do you need traditional data scientists that just understand big data? Do you need high-performance computing specialists that understand how to put together large clusters of GPUs? Do you need AI technologists, people with experience in the deep learning frameworks? And actually, all three of those are things that you need. What tools will you use? Right? Do you use MXNet? Do you use TensorFlow? Do you use Microsoft's Cognitive Toolkit? Some of those decisions may be based on other decisions you've already made. What are you using a public cloud? Are you using on-premise type systems? So characterizing the types of problems that can be solved in deep learning, there's sort of four general sets of problems. One is different types of virtual assistants, answering questions. The second would be generating insights. I have data. I don't understand the characteristics of that data, but I have examples of labeled data. This consumer ended up buying this type of product. This consumer paid for their loan on time or made their payments on time. Automated manual processes, another very good example of data. And finally, unlocking information out of unstructured data. Right? And then unstructured data is any sort of data like voice, video. Most of the data generated on your mobile device, on your cell phone today, is unstructured data. People often think of the inputs, and many of the early examples of deep learning were based around images. Right? Google identifying the images in a YouTube video. And of course, Siri, Google Now, Cortana, all working with voice data. Voice data, because it's so commonly used as an example, and image data we use because most of us are visual thinkers. We can think of an image, we think of that as an example of a neural network. It turns out that there's many different types of data, right? Any data that is time series data, right? X data over time, XY data, if it can be plotted as on an XY graph, then in effect to the computer, it looks like a picture, right? And it can be processed using a deep neural network. The types of tasks have several names, right? Detection, classification, segmentation, prediction, and recommendation. And here's the examples, types of questions that you're going to ask. And these are all different types of segments. And if I apply those to a healthcare example, it might be one, looking at a blood sample and detecting if there's a certain if there's cancer in that blood sample. Classification, saying, okay, this data shows that there's cancer, but what particular type of tumor is it? Segmentation, again, might break that up by size of the tumor, shape, analysis. Prediction, predicting the survivability rate. And then recommendations, what sort of treatment should I have based on that? This is a very interesting example that I saw at a university just several months ago, is they were looking at white blood cell data, and they were able to predict for prostate cancer the survivability rates, and make a prediction on how long someone would live given a certain type of prostate cancer. Now, prostate cancer is studied a lot because it's one that is caught early enough. It has a very high ability to be cured, over 90%. But the problem was using traditional machine learning analysis of all the data, they were only able to get within a 50% accuracy, or within a 50% accuracy, they were only able to get a 3-year or life prediction within 3 years. Well, it turns out that with prostate cancer, it's either cured, or the mortality rate is typically within 6 years. So if all you're guessing, if all you're telling from the data is 3 years of accuracy, it really is then just 50% accuracy, right? And again, they were able to improve that accuracy to above 90%, which then led them to having much better treatments for that. So let's look at an example of classification. Again, thanks to Google and many other websites today, right? You can upload a picture and get a probability listing or tagging of what's in that image, right? This one doesn't have percentages with it, but out of a neural network, you would typically get a prediction accuracy, right? So in this case, I might say this was a picture of nature, or more specifically, it's also a picture of a squirrel. Now, detection goes beyond simply predicting what's in an image and saying, where do I detect, where are the specific objects of interest? So if I'm looking at a photograph, an aerial photograph, and want to say, where are the houses, right? And again, in this particular example, it might be looking at, what's the, where would I put a solar roof if I wanted to put solar energy in? What percentage of this particular area of the block could have solar energy on it? The next step, segmentation, is saying where are the objects of interest and where are they in the image? So again, it's one thing to say there's a golden retriever or a dog in the picture. There's another thing to then segment that image and say where exactly in the picture is the golden retriever. Now, I love dogs. I've always grew up with dogs and had dogs. So if I'm building software for a self-driving car, the segmentation is a lot more important than just the classification, right? You want your car to know there's a dog in the road in between the two lanes that you're driving on versus there's a dog that's on the sidewalk on the side of the street. So segmentation, a very, very important part of deep learning. Now, I'm not sure why the text was crossed out on the chart here, but this was actually an example that an NVIDIA engineer came up with and developed running on a Jetson TK1. And what this engineer did, this engineer apparently liked dogs and not cats. And some of his neighbors' cats were coming over and going on their property. So what he did is he took his sprinkler controller and he hooked it up to an NVIDIA Jetson TK1 at the time, and then he hooked that up to a video camera. So whenever the video camera noticed a cat walking on the lawn, it would turn on the sprinklers. If it noticed a dog walking on the lawn or the neighbor's child, it didn't turn on the sprinklers. That would have been cruelty to dogs, but I guess he was okay with cats. A lot of examples sometimes, identifying cats or dogs in images, right? While they have very important analogies in things like building a self-driving car, right? If you're not in the automotive business, you say, well, really, is there a big business impact? Again, in improving the customer experience, right? Everything from being able to make sure that when I get shipped a package for delivery, that the right products are picked off the shelf and put in that basket or in that box to deliver, all the way to actually perhaps someday doing the delivery by drone. So there's a lot of areas where if you want to get started in your company with AI and with deep learning, think about where is there going to be the most business impact. If you can start small and start fast and have some quick wins and results, you're going to have a lot more. You're going to have a lot more success getting other stakeholders in the company to look at the technology. Now again, today, in the past, when you wanted, a new copy of Microsoft Office installed on your system, you would go talk to IT, and an IT engineer would set that up for you. The data scientist role, we talked a lot about before. Data science is increasingly important to understand where do I get data from, what types of data do I have, ultimately understanding what that data represents. Again, maybe not by understanding all of the details of the data as you would in machine learning, but things as simple as understanding the attributes of the data to label it. We were working with a large phone company, and of course, phone companies, especially wireless carriers, have a lot of problems with, when there's more than one wireless carrier, of you switching from one carrier to another. And that's a very hard problem to detect. Another problem that they have is they say, well, once you're late on your payment, if you're 60 days late, should I continue to give you credit for your wireless phone, or will you not pay, and should I shut off your phone? So one telco company in Asia that we had worked with, they took a traditional machine learning approach. And again, they had over 10 million records of customers that were more than 60 days late. And again, they were using traditional machine learning approaches and statistics. There are so much data that your mobile subscriber knows about you that they were never able to map that to a good machine learning problem. And the best they could get was about 50% accuracy. Well, again, if you're trying to tell if someone is eventually going to pay their bill in 50% accuracy, you could just flip a coin. Right? That's not really worth getting on anything. And then it turns out one of their engineers downloaded the Microsoft Cognitive Toolkit. All of their data was in a Microsoft data warehouse. And he said, I figured it out. They actually had the perfect set of labels for their data. They had 10 million records of customers that were 60 days late on their payments, and they eventually knew these customers either paid their bill or they didn't pay their bill, right? It was a yes/no label. This customer paid their bill, customers didn't pay their bill. And so they fed in all that data into the Microsoft Cognitive Toolkit. They let the deep neural network then organize itself, set the weights, and they were, in just a matter of several days, went from 50% accuracy to over 90% accuracy. So a very quick business impact based on data science. So what are the deep learning tools? The most common ones that you've probably heard of are the deep learning frameworks. Tools like Caffe, MXNet, and new ones being developed every day. I expect next year, when we're here for Computex, this list of deep learning frameworks will be at least double that. And probably in 5 years, it'll be smaller than this list. They'll consolidate down. But today, the deep learning frameworks are some of the key tools for deep learning. One of the challenges with these frameworks is they're often designed by computer scientists. And so the computer scientists, people like my son, love using them. A data scientist, not so much. So NVIDIA Digits, the deep learning GPU training system, is basically a set of tools that sits on top of the framework and lets you do some of those common tasks like classification and segmentation. So it's basically a super framework that sits on top of the framework and lets you organize your data, organize your workflow using a number of the different deep learning frameworks underneath. Finally, if you're at a university, if you're at Microsoft or one of the other framework vendors, you're probably using different parts of the NVIDIA Deep Learning Software Development Kit. These are tools like cuDNN, the NVIDIA Common Collectives Library, and other libraries here. Now, the great thing about these tools, and again, a lot of people think of NVIDIA as a software company, or as a hardware company. And we have some great hardware engineers. We have about 10,000 engineers at the company, and more than half of them are actually software engineers. And since cuDNN, the CUDA Deep Neural Network Library, is used in virtually all of the deep learning frameworks, what that lets us do is when we come out with a new GPU, like Volta with the tensor cores, we can update cuDNN, and as soon as one of the frameworks has the new GPU available, they automatically just relink the framework with the latest version of cuDNN, and they immediately get it all. They can take advantage of all of the underlying features of the new GPU without having to reprogram everything in CUDA. So today, if you look inside the source code for one of the deep learning frameworks, much of the common code is not written in CUDA, but is actually written in one of these higher level NVIDIA libraries. So what are some of the challenges? Certainly one, as we've said, is finding the data scientists. It's a new computing model, and so universities, right, didn't teach deep neural networking 5 years ago, unless you were at University of Toronto or Stanford or small numbers of other ones. Today, more and more universities are teaching that, and again, whether it's tens of professors here in Taiwan, hundreds or thousands in other countries, we are seeing more and more data scientists coming out of universities. You can also retrain data scientists, right? Take people from adjacent fields, take people from the machine learning space, take anyone that has a good computational science and mathematics background. Again, think of that matrix multiply that the tensor core does. If you understand, if you're if you understand math, right, if you're a math major and understand what it is to do a 4x4 matrix multiply, right, you have a fairly good start into becoming a data scientist that understands deep learning. Certainly the latest algorithms. One of the things that we've seen is because AI grew up over the last 5 years so quickly out of the academic space, in all of the big early companies, Microsoft, Facebook, Google, what do? So many of the people they hired were out of academia. Well, what did professors want to do when they went to Google? They said, well, I'll come work at Google, but you need to let me continue to publish papers. So Jetson showed some of the numbers today, right? The huge increase in the number of papers and articles written in deep learning. There isn't a day that goes by where there isn't a new algorithm that's involved, that is developed. And so keeping up with these, having some people in your organization that keep up with these is important. Having the fastest training. This really is linked back to that productivity and actually linked back to the lack of data scientists that really understand deep learning. Right? If I'm paying $100,000, $200,000 US for a data scientist, do I really want him or her sitting around and waiting 2 weeks to get results? Now again, if you're at a company that provides lots of free food for lunch and back rubs and bikes to run around campus in, that's great. Maybe they like having those 2 weeks off in between, while their systems train. But in general, right, most companies, right, they want their data scientists to be productive. And so that's why NVIDIA continues to put more and more improvements in our GPUs, in our software, in our systems to increase that training time and make new types of deep learning possible. Finally, the deployment platforms, right? Again, whether it's in the cloud, whether it's in your own data center, or whether it's on your PC, right? Different individuals are going to work in different areas, and different problems have different scales. We actually found that in NVIDIA, the DGX station, the workstation that Jetson showed today, we have about 100 of those that engineers inside the company are testing. And we actually have a very large DGX1 compute cluster. It's called Saturn V. It's 124 DGX1s, or over 1,000 GPUs. And it's the 28th fastest supercomputer in the world right now. And Jetson said, well, we built this large supercomputer for deep learning. How come everyone has, how come I have 100 engineers that have the DGX station? Well, sometimes having one big supercomputer for doing the training is great, but other times just having something that's whisper quiet, that is at your desk, that you can load your data directly on it, right, has advantages too. So again, having different deployment platforms of all sizes, of all shapes is important. And provide the right ones to your right users for the right tasks. Now, one of the things that we haven't talked about yet is the NVIDIA Deep Learning Institute. About a year ago, I remember we were actually in Japan with Jetson, and we were doing a review. And Japan was was actually where the Deep Learning Institute started. Is Japan had given over the last 3 years, and Japan has not been in this wave of deep learning and AI. Japan has maybe not been as successful in some other countries. But in the past, in earlier waves of AI, right, Japan was very well known for their AI work. And so our Japan office had run a series of deep learning days. And they had had the first one they had about 3 years ago, and they had 100 people show up. And finally, the one they had about a year ago, they had over 1,000 people show up at it. So Jensen, asked, he said, well, why are all these people coming to learn deep learning from NVIDIA? Right? And it's again because we were providing them that focus on specifically how to use the NVIDIA deep learning tools. And so we decided to name that the Deep Learning Institute and take that system out across the world. So last year we trained over 20,000 engineers and data scientists around the world. And at GTC this year, we announced that in the coming 12 months, we plan to train 100,000 data scientists through the NVIDIA Deep Learning Institute. This is a series of courses that can be delivered online or in person, and is over 40 different courses, and they tend to be focused around a specific end use. How do I build an autonomous drone? We co-authored one course with Udacity, the world's largest online training site, on building a self-driving car. They had 250 spots in the class for it, because at the end, everyone got to load their software on an actual self-driving car with a Drive PX in it. And they had over 20,000 students applied to take the class. We ended up donating some more Drive PXs so that they were able to take 250 students, but been a very successful program. Of course, for fast training, there's the DGX systems and the new V100, as well as the existing P100 that is shipping and available today. And then all the different deployment platforms. Of course, there's the NVIDIA GPU cloud. Jensen talked about this in the keynote, but it's worth repeating again. The NVIDIA GPU cloud is not a physical cloud like Amazon or Azure is, but it really is a platform. It's a repository that lives in the cloud. And initially for the DGX1, we used NVDocker, and we optimized all of the common frameworks. We came up with an optimized version of TensorFlow. We came up with an optimized version of Caffe and of MXNet for DGX1. And that was the start of the NVIDIA GPU cloud. And something very interesting happened, right? Is those containers were so popular that that many of our customers started asking us. They said, well, can I use this on another server, right? Can I use this in the cloud? And the challenge is, right, most of the 10,000 engineers at NVIDIA are busy helping or building new products, right? They're not doing customer support. If you go to a big computer company, they maybe have thousands of people, thousands of engineers doing customer support. And so with DGX1, when we supported TensorFlow and NVIDIA in NVDocker, or supported Caffe in NVDocker, we only had to do it on one server. So that we were able to do that with a small support team. So the NVIDIA GPU Cloud is really just the next step of that. It's supporting that same set of software on our Titan X GPU and a PC, and also supporting it in the cloud. Remember, the cloud vendors are increasingly using the HGX platform, which is what DGX1 is built on. So when a cloud platform, when Azure or Google or Amazon Cloud, AWS, deploy GPUs using HGX, we've already done most of the work for DGX1 to do the support for that. So it's fairly simple to add support in the NVIDIA, what we're calling now the NVIDIA GPU Cloud. And again, it's available today, running on a DGX1. again, not in the pure cloud sense, and then we'll be in early access in full cloud mode in July. So again, as you think of getting started, think of your end-to-end product or end-to-end platform. Again, you should always think of breaking it up into training and into inference, the two basic steps, and think about what platform you're going to use for both. A lot of times people say, well, should I use a DGX1 or DGX station, or should I train in my data center, or should I train in the cloud? And especially with the increasing adoption of HGX1 and of the NVIDIA GPU cloud, it really makes it almost seamless in where you want to do that. And it goes back to the first slide of the last presentation, is where is your data, right? If your data is all born in the cloud, right, and on an IoT device that's connected to the cloud and stored in the cloud, it very much makes sense, all other things being equal, to do your training in the cloud. If your data is on a large medical imaging device sitting in your hospital, and all that data is stored in the data center for your hospital, it probably isn't going to make sense to move all that data to the cloud to train in the cloud. You know, a lot of times companies, for competitive reasons, don't want to put their data in the cloud, or have regulatory or privacy reasons that today may still be an impact. And again, today, if you want to drive PX2, right, your only choice is to buy a Tesla Motors car, right? And they're still a little bit expensive, though I hear they have a lower price model coming out soon. But from Audi to Mercedes to at GTC several weeks ago, Toyota Motors picking the Drive PX platform. Even people that don't know anything about deep learning or inference will be using the NVIDIA platforms. So a couple things, if you want to learn more, this was just sort of a 1-hour summary of how to get started. October 2nd and 3rd, here at the International Convention Center, we're going to have the NVIDIA Deep Learning Days, so 2 days of the Deep Learning Institute classes. And so again, we'll have a tremendous amount of more training there. And finally, the NVIDIA Deep Learning Institute. So again, this is something that we can come out and we can bring to your university, we can bring to your company, we can bring to your startup. And again, the URL is there. You can get started on that. But again, we also give on-site workshops, and we have a number of instructors here in Taiwan, and we've already held DLI sessions at some of the largest commercial companies in Taiwan. And finally, while this has been a great AI day here, the best way to connect with the experts, if you're a developer, is to come to one of our GPU technology conferences, if you're able to travel. So we just finished the one in the US earlier in May. So the one down there in Silicon Valley, March 26th to 29th, is 2018. Be the next major GTC in Silicon Valley. All the other ones in those cities are future dates coming out in 2017. So if you happen to be in one of those cities one day, it'll be great to see. I'm sure, at every GTC, Jensen likes to have some special announcements. And so while we have the most announcements at the Silicon Valley one, we always have something in each of these. So with that, thank you very much for coming. And the exhibits are going to be open for another 2 hours, I believe. So please go in and visit the exhibits and visit some of our partners out there. Thank you very much.